Okay, guys, welcome back. So, we're going to basically cover, I think, in the next focus or the next set of focus, we know we're trying to implement C sharp scripting. That's just our main purpose. So, we'll check that off the list. Skipping the hard parts, again, we're not really skipping anything. I mean, I am. What I mean by skipping is I'm skipping a bunch of necessary theory and whatever to really cover the subjects adequately. Um, the reason I'm doing that is because I'm going to cover a little bit about Lisp and expression trees. And when we actually start to build our scripting, we're going to see what I'm skipping, like the things that you really should know if you really wanted to build your own language. You should know what it means to parse something and what it means to lex something. You're going to get exposed to that in this series. So, and specifically in this sub-series, you're going to get exposed to what it means to lex and parse. It's a big topic. They're really big topics, and if you really want to know the details of them, yeah, they're hard parts. So we're skipping the hardest part about all that. But what we're doing is we're easing you into, well, what does that mean? Can you see the power now? Why would you care to parse and lex? That's really what I'm skipping you towards, is so you could see, like, oh, cool, I could do this, and here's how I can do this. I've done it before. Now let's go learn more if I ever wanted to do more with that. So that's the point of skipping it. We're going to look at Lisp, and we're going to look at expression trees. So we're going to focus on these three things right away, and we're not done with them yet. So I told you what I'm skipping. So we're really going to focus on these next two items right here. All right, Lisp. What is Lisp? Lisp is a really old language, but it's extremely powerful just because of its simplicity. Let's see, you could read the history on it. It developed in 1958. You know, it's goes way back, way back. It's got a, I learned it here for AutoCAD way back when, in, I don't know, the late 90s or something, and it was, I thought it was powerful here. There's a lot more. Sorry, not Visual. I learned AutoLisp, and then later on, Autodesk came out with Visual Lisp for AutoCAD, which was cool because it opened up, the Windows way, or the COM, dealing with COM objects back then, and now it's .NET objects or whatever. But anyway, that's my own little story there. Most people probably couldn't even relate to that, but that's okay. Anyway, it just goes way back. It's a real solid language. It's been, Scheme basically is a variant of Lisp. It's, it's still being used today, and there's a lot of just cool parts about the language that I think a lot of people aren't really aware of. So, what are we looking to accomplish with Lisp, and why did I choose it? So, let's look at that. So, what we need to realize is that it's a function-first language. And what I mean by that is there is, I'm going to pin this, and I'm going to close my existing one. Don't save, because we'll basically recreate that. So function first, meaning, hey, there's a function that needs to operate. Let's see. So like here, I need to add these numbers. Well, the add operation comes first, and then all my parameters to my function come after that. So we would normally say, 1 function 2, function 3, function 4, where this one just says function 1, 2, 3, 4. So there's an order to it. The other aspect of Lisp is anytime we have a open parenthesis, we have a closed parenthesis. So if I have 1, 2 open, I have 1, 2 closed, and that's same for, I got 1 open here, 1 closed there, got 1, 2 open, 1, 2 closed. So no matter how you look at it, that's always true. So 1 open, 2 open, 1 closed, 2 closed. So that's a very cool thing about the language. No matter what statement you look at, that's always true. So that's really all I need you to realize about the Lisp language. We'll get into different things maybe later, like what it means to defun. Defun means define function, right? So, and then we create a function foo, and then here's all the parameters to that function, and then here's the body of that function, right? So foo is a sum of A through D, A, B, C, and D. So it could have said sum of 4 or something like, but they just called it foo, whatever. And then we could run foo by typing in open parentheses foo space, and then put 4 numbers in there, and then in parentheses hit enter, and it would execute the function foo. So that's the way that works. Anyway, enough on that. That's all you really need to know about Lisp. You'll get to see how we parse that, lex that, how to create your own functions at some point, how to detect built-in. So these are things I would consider built-in functions, like times and multiply, and right. So these are built-in operators, I guess, but they're functions. As far as I'm concerned, it's a function of how to add 2 things together. It's a function of how to multiply 2 or 3 or 4 things together. So we're going to go through that. Let's see. Now I wanted to talk about expression trees and why Lisp lends itself to these expression trees. So let's go ahead and pop this open. Now we are going to need something a little thicker. There we go. So we're just going to start with this function because we have A, B, C, and D defined, but our ultimate goal is for this first part is we need to parse through, and we need to make sense of and evaluate and execute basically something. So I just chose this times A and B, close that so that parenthesis, and then times C and D, and then we'll close the whole thing off. So we know that we're function first, so we get this function, we get this function, we get this function, and then so we got to realize that this is the outset, right? This open parenthesis is paired to that open parenthesis, and based on your order of operations in some basic mathematics, right, anything inside of the parentheses happens first. Well, these are at the outset, so we have parentheses inside that we need to operate on first. So these two are at the same level as these two, and now we're digging in. So we have to figure out how do we parse that. Well, we'll get into parsing, but what I want to show you is the expression tree. So we have this expression first, right? We have these inner ones first, and then we have the last one. So what we do is we start at the last one, which actually comes first, right? It comes first, but it's the last evaluated. So I'm going to just resize that a little bit while we're talking about it. I'll resize it just because I drew really big. But there as a reminder. And let's go back to here, and we're just going to start at the outset. So on an expression tree, we start the last thing first. That's the root of the tree. And then we break off left and right. What happens left and right? Well, one of the things that needs to happen is this one at that level and this one at that level. So we'll just keep this on the left side and this on the right side. So, but it's a function first thing. So there's a function there, and we need to put that function expression there. So it's a multiply, and then we got to multiply over on this side. And then over as parameters to that, we have A, and we have B, and we have C, and we have D. Okay. So now, what do we do with that? Well, remember we defined some. I pretended that we scripted those and we added these to our dictionary of variables. So A is 10, B is 20, C is 30, D is 40, right? They just increment by 10, A, B, C, and D. Starts with 10, increments by 10, 10 to 40. Okay, so just keep that in mind. So A gets replaced by a value, right? So we'll cross that out. That gets replaced with its value of 10. B gets replaced with its value of 20. C gets replaced with its value of 30. D gets replaced with its value of 40, right? Now, then we go through and we do the operation, because we're trying to get up to the top of the tree to where there's no more operations to be done, okay? So to do that, we would evaluate this whole thing, and this whole thing would return 200, right? And then we would evaluate this whole thing, and this would return 3 times 4, 12, add 2 zeros, 1200, right? Okay, and then we would need to operate on this item, and 200 plus 1200, well, that's 1400, and then we're done. There's like that replaced this, that 1400. Sorry, I didn't make it 1400. There we go. That replaced this. This replaced that whole group of items. This replaced that whole group of items, and then it just moved up the tree. So you see that's all there, right? This, let me change the color here, right? This whole plus operation, we saw where that went. That went right here. This one went right there. This one went right there. And then A, right, whoop, hop, went right there. And B, we'll hop again. There you go. And that went right there. And then starting to get ugly with the colors here, I guess, but I'll pick a dark red maybe. All right, C went right here, and D went right here. So we see every aspect, every line, right? With the exception of the parenthesis itself, every item in here. This one, this one, this one, this one, this one, this one, and this one, right? This D. Every one of those items went out into that expression tree, and we built it, and we solved it, and we evaluated it. We did it manually. We did it by our own reasoning, but we did it. And now if we do it by our reasoning, we can tell the computer to do it through reasoning we program into it. So anyway, I just wanted you to see why I'm choosing Lisp, and that Lisp just inherently in its structure, it forms or has the ability to quickly form these expression trees. So I just want to show you that that's kind of the idea behind the language. Let's see. There we go. I wanted to see this image. I don't know why it disappears, but anyway, you can see it's kind of forming these expression trees just inherently in structure, and that's the coolest part about that. So let's call this video good. So stay tuned, stay subscribed, or get subscribed, and pick up the next one. The next one we'll cover is well, we solved half of this list, right? So now we're just going to get in and we're going to start doing the cool parts. So now that you have a little bit of basic theory, that's basically all the theory you're going to see or need to learn right away before we dig in. Now it's just about getting our hands dirty, and we'll learn along the way. So, and just have fun with it. That's what I'm hoping for, is that we just start to see the power, start to use it, and just learn more about what you need it for. So anyway, let's call that good. I'll see you on the next one.